This is Rivers Cahill, and this is my water quality project. Introduction. The Waccamaw River in Conway, South Carolina is a scenic and biodiverse river system that has a significant impact on the local ecosystem, according to winyarrivers.org. This river is an important part of the region's culture, providing water for irrigation, transportation, and recreational activities. The Waccamaw River is home to a diverse range of wildlife, including fish, turtles, otters, and a variety of bird species. winyarrivers.org. The river system is complex with many different factors influencing the water quality, including human impact. The human impact on the river includes pollution from agriculture and urban runoff, as well as the effects of dredging and cutting down trees around the river. The presence of various wildlife in the Waccamaw River plays a crucial role in maintaining the water quality, according to winyarrivers.org. For instance, turtles are known to eat dead plant matter, which helps prevent the buildup of algae and bacteria as the water temperature increases. It is likely that the water quality and pH level of the Waccamaw River will change. Higher temperatures can lead to an increase in the growth of algae and bacteria, which can have a negative impact on the river's ecosystem. It can also cause an increase in the water evaporation, leading to a decrease in the river's water level, which can be damaging to the local wildlife. In conclusion, the Waccamaw River is a vital part of the Conway, South Carolina community and is crucial to monitor and maintain its water quality. The ongoing six-week water quality testing in the area is an exciting initiative that will provide valuable insights into the river's health and the impact of human activities on the ecosystem. Location. Gray Oaks Drive, Conway, South Carolina. This is where I chose to conduct my water quality project on the Waccamaw River. This is where I visit a lot and have a dock to go on and test the water in this area. Here's a picture of the wetland. Wildlife and humans. This area is interesting to me because of the abundance of wildlife and the abundance of people in this given area. There are houses and boat traffic along this area, which I want to see how this affects the quality of water in the area. Wildlife spotted. Here's a catfish that we found. On February 3rd, the organisms observed were small brim, minnows, insects, and birds. It was rainy, cloudy, and there was not much movement outside. On February 10th, there were small fish and birds. Cloudy, not much movement. On February 17th, I spotted turtles, fish, and birds. And it was sunny outside and there was more life moving. February 24th, fish, turtles, birds, lizards, and water bugs. There was an abundance of wildlife because of the temperature outside. March 3rd, fish, water, bugs, turtle, and frogs. It was sunny and the wildlife was out. March 10th, there were small fish. It was windy and dark outside. March 17th, fish, turtles, snakes, bugs, frogs, and birds. It was sunny outside and wildlife was out. March 24th, fish, turtles, snakes, bugs, frogs, birds, and deer. And it was sunny and the wildlife was out. Results from testing the first 6 weeks. On February 3rd, the pH was 6, dissolved oxygen was 4 ppm, nitrogen was 5 ppm, the temperature in Celsius was 13.3, and the weather outside was rainy and dark. On February 10th, the pH of the water was 6, dissolved oxygen was 5 ppm, nitrogen was 4 ppm, and the water temperature in Celsius was 14.4, and it was cloudy outside. On February 17th, the pH of the water was 7, dissolved oxygen was 5 ppm, nitrogen was 5 ppm, and temperature was 15.4 Celsius. The weather was sunny. February 24th, pH was 6, dissolved oxygen was 6 ppm, nitrogen was 5 ppm, and temperature was 16.5 Celsius. The weather was sunny. March 3rd, pH was 7, dissolved oxygen was 6 ppm, nitrogen was 4 ppm, and temperature was 16.9 Celsius. The weather was partly cloudy. March 10th, pH of the water was 7, dissolved oxygen in the water was 6 ppm, nitrogen was 5 ppm, temperature of the water in Celsius was 17.5, and the weather was sunny. Hypothesis. My hypothesis was that my site has a good water quality and an abundance of wildlife and will continue to have a good water quality throughout the experiment and have more wildlife out as temperatures continue to rise. Materials used. 10 dissolved oxygen tablets, 6 pH tablets, 6 nitrogen tablets, 1 small glass vial for testing dissolved oxygen, 4 water collecting containers, 2 separate teaspoons to test water quality, small clear container that you can fit 2 teaspoons in, and a thermometer. And here's one of the sampling cups that I used. Methods. Here's a picture of my wetland. The wetland description is that the wetland has a dock and plenty of forest resting around it. This makes it applicable to test the water to sample. There are other houses on one side of the wetland, and on the other side is a forest. There is a beach as well, which you can go on to test the water, closer to shore. The water is brown and the visibility is low. The method I used was to go on the dock and reach down off the dock to grab some water. I would then repeat this process to get small samples to test for each of the required measurables of the water quality experiment. Methods Part 2. To test for pH, dissolved oxygen, and nitrogen, I inserted the various different tablets into the samples I took the dock off the Waccamaw River. I waited for various times to see what happened, and based on what happened, I would conclude the results from the various measurements and write them on the chart. To test for temperature, I would stick a thermometer into the water and record the results on the chart. To test for pH, I would insert one of the pH tablets. To test for dissolved oxygen, I would insert one of the dissolved oxygen tablets. And to test for nitrogen, I would also insert one of the nitrogen tablets into the various containers. Results of water quality. The results I gathered from this experiment were that the pH of the water stayed consistently around 6 to 7 pH. Dissolved oxygen increased from 4 ppm to 6 ppm over the testing period. Nitrogen fluctuated between 5 and 4 ppm throughout. Water temperature increased over time from low 13 Celsius to 17.5 Celsius over the experiment. Wildlife spotted increased as the water temperature increased and as the outside temperature increased. Results continued. And here are some line graphs I made to show the results over the experiment for the various testing measurables. Here's dissolved oxygen and ppm increasing over time. pH over time is fluctuating from 6 to 7. Nitrogen ppm is fluctuating as well, and temperature Celsius is increasing at a pretty constant variable over the experiment. Discussion. The brief summary of my results is that the pH of the water stayed consistently around 6 to 7 pH. Dissolved oxygen increased from 4 ppm to 6 ppm over the testing period. Nitrogen fluctuated between 5 and 4 ppm. Water temperature increased and wildlife spotted increased as the water temperature increased and the outside temperature increased. According USGS Rivers shows that this would occur because temperature increased. My hypothesis was that my site has a good water quality, has an abundance of wildlife, and will continue to have good water quality throughout the experiment and have more wildlife as temperatures continue to rise. I accept my hypothesis and believe that the results of my experiment back it up. Also, according to NASA, the optimum pH for the river water is around 7. This backs up the water quality is optimal in my testing location. Discussion continued. The data appears the way it does because of the healthy water that is in the area. The temperature is relatively neutral on this side and there is not much pollution from runoff because there are no farms around and only houses and boat traffic could damage the water quality. Ways to improve my experiment would be to continue sampling into the summer to see how more boat traffic could influence my results, as well as take samples more than once a week to see the difference there. Conclusion. The conclusion of this experiment is that water quality at my wetland that I tested has good water quality and is healthy for wildlife and humans to thrive in this area because of the neutral pH. Not too high levels of dissolved oxygen and not high levels of nitrogen in the water. All these factors lead to a healthy wetland and an abundance of wildlife as seen and documented throughout the experiment. And here's my works cited in MLA format. And that concludes my presentation.